Good afternoon, everybody. My name is Stijn Jansen. And first of all, I would like to welcome you to this webinar, which is organized in the framework of the Paso Doble project. The content of this webinar is as follows. So I will start with a rather general introduction of the multi-scale problem we encounter today in air pollution, and then especially point out the challenges that city authorities are facing today. And based on this analysis, I will describe two different services we've developed at Vito over the last couple of years for these urban hotspots. In the first service we developed, I will describe a rather classical impact assessment study. And I will use the Antwerp Air Quality Management Plan as an example to illustrate our methodology and our approach. Then, in the second part of my presentation, I will focus on the IFDIM traffic web-based modeling tool we've developed for local consultants, and which can be used for air quality management planning as well. And so then I will come to conclusions, and this part will take about half an hour, maybe 35 minutes. And then there is plenty of room for questions. So about these questions, if you have questions during the presentation, you're pleased to submit them using the panel on the right. So if your panel is minimized, you can use the orange button to expand it, and then you can enter your questions into the screen. And I'm happy to take a couple of questions at the end of my presentation. So, as I said during the introduction, this webinar is organized in the framework of Paso Doble. Now, the overall goal of Paso Doble is to develop a set of what we call downstream services, which are specifically designed for authorities at the regional and the urban level, and which aim it is to come up with some useful and easy-to-use services for these local authorities. And in that respect, it's complementary to the MAC project, which is also funded under the CMGMES program, which is focusing on the course, which is a so-called core service, and is focusing on the entire European domain. So within Paso Doble, we have about 35 downstream services to support local actors in the field. So today it's realized that air pollution is a multi-scale problem, and when we look at the continental scale, and for example here you see a picture over Europe, you clearly can see that some individual cities, but also some important regions, or some regions show up as important regional hotspots. So we have, for example, a clear picture of Paris here, Madrid, Barcelona, but then also some regions which are clearly visible, for example, the Po region, but also the region in the northern part of Flanders, southern part of the Netherlands, and western part of Germany. And so at this continental scale, regional hotspots are clearly visible. When we then zoom in into the regional scale, we observe that these regional hotspots are actually containing much more detail, and individual cities show up as hotspots on top of this regional background. And so, for example, here this is a zoom over Belgium, and you can clearly see the impact of individual cities, like for example Brussels here, but also the harbour and the city centre of Antwerp, city of Lille in the northern part of France, and some other regions, some other cities in the southern part of Belgium. When we then go even to a finance, individual city hotspots also contain much more detail than seen at the regional scale. And for example, here you see a zoom over the city of Brussels, and there you can clearly see that the air pollution pattern in this case is mainly determined by the highways and clearly exhibit a pattern that is dominated by traffic emissions. And then we go even to a finer, if we go to a finer scale, what we call the local scale, you see that apart from the impact of highways, which is visible here at the bottom of this graph here, which is a zoom of the city of Antwerp, we clearly can see the impact of the ring road. But then on top of that, in addition to that, we can observe that also within the city center, quite high concentrations are observed, and which can be linked to so-called street canyons, where we have quite intense traffic flows surrounded by high buildings, which are in this case responsible for the high concentrations. And so from a schematical point of view, we can say that the impact of a city on the air pollution is as follows. So we start with a regional background which enters the city at its borders. Then on top of that, the city itself adds what we call an urban background. But then very locally we observe some very distinct peaks which are in many cases related to traffic. And it's especially these peaks which are causing in many European cities exceedances of the limit values. And so all these different scales in air pollution we observe today require also policy actions at the different levels. And it's very clear today that mitigation strategies to tackle the air pollution problem have to be developed at all of those scales and the corresponding decision-making levels. So there is a clear role for the EU level, but also at member state level and at regional level. And as I will show during this presentation, also at the urban level, there are quite a lot of opportunities to participate in the process and to tackle the air pollution problem and the exposure of the citizens. And so, especially related to this local authorities, we observe that there are quite some important challenges today. So first of all, it's clear that local hotspots at this urban scale are often caused by traffic. In addition to that, it's also clear today that in many cases and in many cities, traffic can be influenced by local policies and local decisions. The challenge we observe today for many city environmental agencies is that it's not always clear how to evaluate the impact of the different traffic management plans they have on the table, and then especially how to evaluate this in a cost-efficient way. And so therefore, over the last couple of years, Vito has developed a number of traffic scenario assessment services, especially tailored for these urban hotspots. A first type of service is what we call the classical impact assessment study, where we basically set up an air quality model for a region or a city. In close collaboration with the local authorities, make a selection of the mitigation measures which are most appropriate, do a couple of modeling simulations, and then the typical output is an impact assessment report. Another approach is what we call a so-called web-based software tool, which we have given the name IVDN Traffic. And what we do is we configure this software for a specific region or city. On top of that, we develop or we set up a web-based interface. We give training to local administrations and consultants how to use the web-based software tool. And then the output of the project is a web-based model which can be used to support air quality management in the long term. And so during the remaining part of the presentation, I will basically describe both types of services. And so I will start with the classical impact assessment study, and I will use the Air Quality Management Plan of Antwerp to illustrate our methodology. So Antwerp is located in the northern part of Belgium, and it's one of the major hotspots in the region. due to its intense traffic and location of the harbor in the northern part of the city. So the first thing we did when we started with the project was the establishment of a set of quite detailed air quality maps, and we did the exercise for all relevant pollutants. So of course we made a map for NO2 and the PM10 and PM2.5 pollutants, but also for elemental carbon, because we felt that this elemental carbon as an emerging pollutant becomes more and more important also from a health perspective, and also given its clear relation with traffic emissions, the whole analysis is also set up for EC. And so we did the analysis for the entire urban agglomeration at a quite high spatial detail. And so here you can see that all individual streets are modeled, and you clearly can see that also street canyon effects are simulated. So once we had produced this type of maps, of course the question was put on the table: how good is this? How good is this map? And therefore, for us, it was very important to have a validation of these results. And so, in collaboration with our colleagues from the measurement department, we've set up a measurement campaign, and we've sampled during two periods during the year, one during the winter and one during the summer, at about 50 locations all over the city, at urban background, at urban, and also at street canyon locations. We sampled a number of pollutants. And when we then compared the measurements with the model results for both periods, a scatter plot, which is just one of the validation parameters we analyzed, was obtained as given here, and this clearly shows that the general features of the air pollution pattern can be captured by the model, and that the model is suitable to be used as an air quality management tool. So then we worked in very close collaboration with the city authorities to really develop the management plan itself, and therefore we first started with a selection of all the relevant hotspots in the area of interest. And so what we did is we made an overlay of the air quality maps with the traffic intensity data, and based on this we were able to select the relevant air quality hotspots which are directly related to traffic. So then in the second phase we made a selection of feasible policy measures that could be implemented at the urban level. And so in total, after a brainstorm session, we identified about 67 measures. And then for each of these measures, it was defined whether or not it could be implemented before 2015, because that was an important boundary condition. On top of that, we analyzed the possible impact of each measure on air quality, just based on some expert opinion and some literature review. And based on this analysis, we made a selection of a couple of measures and combined them into an optimal scenario. And then last but not least, and I think it's important to mention here that for each of these measures we also made a cost-benefit analysis, because it was very important for the Antwerp Environment Agency to come up with an air quality management plan, or an air quality traffic management plan, which also from a cost perspective was a realistic scenario. Then all these different measures are combined in two different packages. And so a first package contains a number of rather quick win solutions or quick win measures that could be taken at the level of the city authorities itself. Then on top of that, in a second package, the city was a bit more ambitious, and a low emission zone was imposed on top of the packages selected on top of the measures selected in package 1. And then in a third package, Also measures targeting the industrial sector, which is mainly located in the harbor area to the north of the city, were added on top of the measures in package 1 and 2. And so then all these measures were translated into specific emission reductions, not only total emission reductions but also spatially explicit. So for each street in the city, it was defined what would be the impact of each of these measures, and then these emission reductions were used as input for the air quality model. And then based on starting from the reference case simulation, where we have in this case NO2 concentrations for the year 2015, which is here then used as a kind of a business as usual scenario, the impact of the different packages is estimated. And so what you can see here is the impact of the combined impact of the measures in package 1, which are what we call the so-called quick win solutions. And overall, the impact on, in this case, NO2 was rather disappointing. So overall, urban background concentrations dropped by about 1%, and very locally reductions up to 5% can be expected. But after all, this result was not as big as the local authorities had expected. But then, when we added the low emission zone on top of this first package, we arrived at what we felt were quite significant results. So here in this picture, you see that concentrations drop, urban background concentrations drop with about 4%, 5%, and very locally, then especially in the street canyons, where concentrations are already very high, reductions of about 10 up to 15% can be achieved. So this was then appreciated as a quite significant result, and it also demonstrates that also at a local level you can have an impact in the order of maybe 10-15% on air pollution and the exposure of your citizens towards these concentrations. So I will not go into detail about this part of the study, but also based on the air quality maps we were asked actually to also assess the impact of exposure of vulnerable groups over the urban agglomeration. And so what you see here is the exposure to NO2 concentration and elemental carbon concentrations at all the schools in the city, and so also for the local authorities, this was also very useful information in their planning strategies. Okay, so far our classical impact assessment study. Now in the remaining part of the webinar, I will describe another approach we developed over the last couple of years, and which is more a product-like service, and which basically is a web-based software tool we've developed and we have configured for the Flemish region. So EFDM Traffic is a web application. It's accessible via this web link given here above. And before I describe the methodology and the functionalities of the tool, I would like to describe why we came to this selection of a web-based tool for traffic impact assessment, because I think it's important to explain a bit the story behind it. And so 2 or 3 years ago, it was realized that that there are quite a lot of traffic management plans that have to be evaluated with respect to its impact on air pollution. And so it was also realized that a lot of all these environmental impact assessments are conducted by a rather large number of different consultancy companies and local administrations itself. And so for the Ministry of Environment and its administration, it was really essential to harmonize all the different methodologies that were used in these different assessment studies And not only the methodologies, but also, of course, the modeling tools itself and all the different input data sets that are relevant, as, for example, metrology, but also emission factors, background concentrations, etc. So this was a first observation and a clear need to harmonize the modeling tools. On top of that, it was observed that many of the consultant companies are familiar in developing traffic control plans, but there is a lack of relevant expertise in emission modeling and certainly in air quality assessment modeling. And so all together brought us to the conclusion that there is a need for an air quality assessment tool which can be used by a rather broad public, but starts at the level of traffic data flow. So that was a clear user requirement at that time, that we should start at the level of traffic flows, because this is an important source of information that is available in many cities. And this is the data consultants are familiar with. So a few words about EFDM traffic in general. So the scope is very clear. So it's a simulation tool of air quality along highways and important roads. Okay, we've collaborated very closely with the Ministry of Environment and its administration to develop this software. And these days, since 2010, it's freely available for all cities within Flanders. And the typical users that are using the tool today are regional or local authorities, and also a large number of consultancy companies. And so the tool is set up as a web application, which means that all input and output is exchanged via web interface. And the model calculations itself are executed on a central server via the first in, first out principle. So you launch a model calculation, and a couple of hours later you receive the output. If the server is available, and maybe otherwise you have to wait for a couple of hours. But in many cases, this is not a real problem. Okay, so I will not really in depth describe the methodology, but just to give you an idea of what is required. So the core of the tool consists of two different models. So first of all, we have the Mimosa model, which is a traffic emission model, and we have IFDM, which is a dispersion model, and together they really constitute the core of the tool. So when we want to configure the tool for a specific region, we need a number of input data sets which have to configure it just one time before, in the first phase during the setup of the tool. And typically these are background concentrations, not only for a historical year, but preferably also for some projections toward the future. For example, what kind of background concentrations you expect in 2015, 2020, and if available, we can include different scenarios to take into account different policy levels, or policy decisions at the regional or the national or the European scale. Related to that, we also need metrology because the IFDM software works on an hourly basis, so concentrations are calculated on an hourly basis, so we need metrology data for that. And then we need input data for the traffic emission model. So first of all, we need emission factors, which in many cases just can be taken from the cohort 4 emission factors, which are available at the European level. If local information is available, it can be included. And then that's very crucial, of course. We also need an idea about the fleet composition in the specific region. And also there it's essential to have an idea about fleet composition today or for a recent reference year, but also to have an idea about the evolution of the fleet and future projections. So for example, what will be the fleet composition in 2015, what will be your fleet composition in 2020. And so once these data sets are available, we can configure the software, and then it's ready to use by local administrations or local consultants. And so then, as a user, when you want to launch an IFDM traffic model simulation, you basically have to select a rather limited number of input parameters. So, for example, you have to select which pollutants you want to be included in the output. You have to define your receptor grid and your region of interest, for which region, which city, which area you want model results. You also can select locations where you want to extract some time series. This can be interesting if you have, for example, a measurement network available where you can use the measurements for validation later on. And then the most important inputs actually you have to provide by yourself are traffic flows, traffic data, preferably for a reference year, but then of course also for your scenario work. So the traffic flows for your different traffic management plans. And then as an output, the tool gives you air quality maps at a quite high spatial detail. You also receive emission information, emission totals, but also emission at line segments. You receive time series at the locations you have selected, and of course also a log file with all the relevant information for traceability, etc. So now to demonstrate the use of IFDM traffic, I will make use of an what we call a toy example, which is also used during the training sessions. And so what you see here is an area. You have a highway, an area in Flanders. You have a highway here. You have a city here. And so imagine you're a consultancy company and you're asked to assess the impact of your new project. And so what you're planning to do is you plan to build a new bridge here on top here. At the highway, and you plan to build a tunnel here at the connection road between the city and the highway. And so the exercise is, okay, what will be the impact of this project, this construction? So basically what you need is you need three different calculations based on three different road files. As a reference case, you want, for example, the situation in 2010 to compare with. Then you want a simulation in 2015, which gives you a kind of a projection for the base case without any scenario. And then in a third simulation, within the horizon of 2015, you estimate that your project will be realized, and you want to know the impact in 2015. And so then the impact of the project itself can be estimated when you compare round C with round B, and then the impact of the business as usual, the policies that have an impact, or at least the regional policies that have an impact between, and then of course also the European policies between 2010 and 2015 can be estimated by comparing the base case with the reference year. And so basically the data that is required to calculate those impact assessments are basically three different traffic files, one for the reference situation, one for 2015 without your project, and one for 2015 with your project. And then for each of the 2 years, of course, you want to make use of the relevant background concentrations. So for 2010, you can make use, for example, of measurement data. For 2015, you can make use of any projection that is available about a decrease or an increase, depending on the situation in 2015. And you also want to make use, of course, of the fleet composition for that particular year. So when this information is available, you go to the IFDM traffic login page. And I have to apologize because all the screens are in Dutch, but okay, I will guide you through. So the administration, the regional administration, is in charge of managing all the user requests, and so they provide you with a password. And once you've received that, you can log in free of charge. Then the first thing you have to do is to define your receptor grid. and your region of interest. And so we basically have two types of receptor grids. So we have a regular receptor grid, and on top of that we have what we call an irregular receptor grid, which adds some more detailed spatial resolution along the important roads and highways, and which is required to really grasp the steep gradients that can be expected in the near vicinity of these roads. So you have to define this as an input as an input parameter, and you have to define the specification of this receptor grid. After that, you have to make a couple of extra selections. So first of all, you have to select your fleet composition for the relevant year. You are making a projection within your project. You also have to select emission factors. Depending on the situation, we can include different sets of emission factors, if that is appropriate. Then, of course, you also have to make a selection of your background concentrations and your metrology. Also here, you have to select the appropriate year. You have to select the pollutants you want to calculate, and then when all this information is available, when all these parameters are selected, you can push the start button and your request is submitted toward the central server where your model simulations are processed. And then typically within a time frame of a couple of hours, you're notified that your results are available for download. And then the typical output of such an item traffic run is given here. So this is a map for the run B, where we make a projection towards 2015 without our project implemented. This is the result of run C. It's the same reference here, but here now our project is realized. And we make when we make the difference between both, we clearly can see the impact of both our new bridge that will be built on the highway. So here at ground level we see that concentrations will drop because emissions or pollutants, traffic pollutants are emitted above ground level. And then also the impact of our new tunnel is estimated here. So on top of the tunnel, concentrations are reduced, whereas at the tunnel entrances, concentrations increase. And so this is a typical output which then can be used by the consultants in their environmental impact assessment reports. So this basically brings me to the end of my presentation. So I think it's really clear these days that modeling tools are essential to support the setup of air quality management plans. And over the last couple of years, we have developed two types of generic solutions which can be used for a cost-effective assessment. So first of all, there is the more classical comprehensive impact assessment study, where we're working in very close collaboration with local authorities and where we can make an evaluation of traffic management plans with respect to air quality impact, of course, but also making an estimate of the cost effectiveness of measures that are proposed. And then in a second type of solution, we've presented a product-like service, IFDM, which is a web-based software tool which can be used for local authorities, but also by consultants that work for local authorities. And I think the advantage there is that it's an easy-to-use web interface, and I think that is very important. That the level of input data that is required starts at traffic flow. At traffic flows, which is data that in most cities is available, and many consultants can provide this information for the local regions. So okay, this brings me to the end. Thank you very much, and I'm very happy. I'm very happy to take any questions. So I've seen that some of you have already submitted some questions. So I discuss with my colleague. Just give me 1 minute and then I come back to you. Okay, so a first question is a concentration scale of 1 microgram per cubic meter of NO2 realistic, taking into account the uncertainty of the model? Okay, and let's refer to slide number 17. Probably it's this one, yes. So indeed, I think it's a good question, and it's okay. We have made a validation of the air quality of the overall air quality map based on measurements, and okay, this validation shows that the overall trends are rather well described, and the model is able to describe the concentrations in the different urban environments, for example, urban background versus street canyon effect. Of course, the overall uncertainty on this map is much more than 1 microgram. I think we have to be honest about that. And I think it's given here. Sorry about that. Here. So the overall uncertainty is bigger than 1 microgram. But now to answer to the question, what we are showing here is the difference between 2 model simulations. And so what we do is we use we use exactly the same boundary conditions for the both model simulations, and only change one input parameter. In this case, it's the traffic emissions, which are then related to the measures selected in this package 1. And so by subtracting both model simulations, which for example contain the same metrology, the same building data, etc., we sort out quite a large amount of the model uncertainty, and by comparing model runs, we believe that a much higher accuracy can be obtained. But okay, I agree. I think an accuracy of 1% is realistic. Maybe below that, let's say, whether or not it will be 0.3 or 0.5, I think that's probably within the uncertainty of the model. But okay, that's well known that when you compare 2 model simulations where only just 1 parameter is changed, you reduce a large part of your model uncertainty. Okay, then a second question is, were data regarding building heights used in the local scale model? Okay, I think I can be clear about that. So indeed, for this kind of simulations, it's given here. Indeed, we need quite detailed information about building heights for the entire simulation domain. So if you want to model street canyon effects, it's essential that you have information available about building heights in your city. If not, okay, there can be a backup plan, and you can, for example, estimate, depending on the streets, that all buildings have a height of about 10 meters or 50 meters. But if you want to have as accurate as possible results, it's essential to have as detailed information as possible about this building heights. Yeah, that's for sure. Okay, another one is, okay, I like the web-based tool. How long would it take to set it up in a new city? Is there a long consultation phase with the clients and the consultants? There, I think I can say it depends on the information that is available. So okay, this this picture describes the data that is required to set up the tool. And so basically, during the configuration phase, we basically need to configure this information. So we need to configure background concentrations for historical year, but also for some projections toward the future. The corresponding metrology has to be processed in a correct way, and then also local information about emission factors, if these are available. If not, we can use the cohort 4 emission factors, and then also information about the fleet composition for the situation as it is now or in the recent past, and then projections toward the future. So this is basically the data that has to be processed during the configuration phase. The software itself is now fully available here in Flanders, and it's built up in a rather generic way that it can be exported towards other regions. Okay, and another question is, in what situation you would recommend using the service or the product solution? Yeah, there it depends on the overall objective regional or local authorities have. So if it's the idea to have a quite detailed impact assessment and make an evaluation of an air quality management plan over a rather large domain, I think that the service approach, the impact assessment study, is probably the most appropriate way to go. Okay, we have quite some expertise about possible policy measures that can be implemented, about its impact, about cost effectiveness, etc. When it's the aim to harmonize tools, and I take here slide 23, and to harmonize tools that are used by a rather large number of different consultancy companies and local administrations in your region, and you want to make sure that all your environmental impact assessment reports are based on the same methodology and modeling tools and input data sets, then we really believe from our experience here in Belgium that a software tool as IFDIM traffic can be very useful, and is also useful to support your air quality management on the long term. To give you an example, since mid-2010, when the tool was launched, here in Belgium, we have more than 600 requests for model simulations for environmental impact assessments, ranging from very small projects where just the impact of traffic modifications in one single road were simulated, towards very complex impact assessment reports, where, for example, complete impact of the Brussels ring road, or where the impact where an impact assessment was made of a traffic management plan for the complete ring road of Brussels. So that is basically the two types of approaches. One, harmonizing modeling tools, methodologies for local consultants and local administrations, versus a quite intensive support in the establishment of your local air quality management plan for your complete city, for example. Okay, next question is, thank you for your presentation. Which city departments do use the model in Antwerp? So okay, we did this impact assessment study, I think now 2 years ago, in close collaboration with the City Department of Antwerp. And at that time, different departments were involved in the city. So first of all, there was the Department of Environment. As I remember well, they were the main drivers for the project. But for example, also people from the traffic department were heavily involved. Also people from the GIS department were involved. And so, yeah, quite some people participated in the brainstorm sessions and the evaluation of the different measures. Then, when the impact assessment report became available, obviously this was presented towards the City Council, and then this was the start for a next phase where, based on this impact assessment, a quite detailed study was set up how to implement this low emission zone from a technical point of view. What would be the, how can it be organized? How can it be organized from a practical point of view? What will be the cost? What will be the social impacts, etc., etc. So this clearly was a trigger for another set of studies and another set of discussions within the city and within and with consultancy companies, mainly people that are really dealing with traffic management plans to implement an efficient low emission zone in the city of Antwerp. Maybe another question that is related to that. So which assumptions have you made for the low emission zone in terms of Euro classes? Only heavy duty vehicles or also vans and passenger cars? So what we did is we estimated or we assumed that at that time, so in 2015, no vehicles with a Euro class below 4. So Euro class 0, 1 and 3 are banned out of the city. So which means that in 2015 only cars as well as heavy duty vehicles and vans with Euro labels 4, 5 and 6 can enter the city. But as I said before, this then was a first estimate, because if you really want to simulate this in very great detail, we know from examples in other European cities that you really have to simulate also the side effects. For example, people that have a Euro 3 car but live outside the city maybe just keep their car but then don't enter the city, the low emission borders anymore, but they just keep on emitting at the borders of the zone. So this kind of secondary effects were not taken into account, but they were considered in the follow-up project, where a more in-depth analysis was made about the technical implementation of the zone. Okay, then another question is, what are the chances to use a system outside Flanders? Do you think about preparing in this version? I think that's a good question. So up to now we've developed the IFDM traffic software in close collaboration with the Flemish administration, the Flemish Ministry of Environment. But the software is now available, and I think it can be implemented in other regions in Europe. I think important there is that, okay, we have to see if all relevant input information, as I said before, boundary conditions, background concentrations, etc., is available. But when this is available, I think it's not so difficult to install it in other European regions or cities. Okay, and another question is, how do you usually calculate future background concentrations? I think that's an interesting one. It's okay to calculate this future background concentrations. This cannot be done, of course, with the modeling software, the modeling tool I've presented here. So basically, what we do is we use a regional air quality model, which is which is then nested in a regional, in a continental scale model. So basically we use a combination of modeling tools which are relevant for the continental as well as the regional scale. And for example, to calculate future scenarios for 2015, we take into account all relevant European policy measures, as well as some measures which are decided at the regional level, implement these as appropriate emission input files, and then perform a model simulation of the regional background. I have to say here that there is a tricky part related to that, because we know that this regional or continental scale models in many cases are not representing the true concentrations very well. Especially for PM10, we know that there are significant underestimations of the measured concentrations in many regions in Europe. And so basically what we do is we do two different simulations. We do a simulation for a reference year, for example 2010. We do a comparable simulation taking into account policy measures for 2015, and then define the difference between both rounds. So we define the difference between 2015 and 2010. And then this difference is used in combination with measurements. And so then we use measurements in that case for 2010 and use that as a reference case, and then apply the reductions which are given by the models, the regional model simulations, as a future projection for the background concentrations. So okay, I don't know if my answer was clear. With a quite detailed description of this methodology. So if you're interested into that part, I'm very happy to explain it in more detail afterwards. But indeed, it's a very relevant question, and that's something we've seen in many cases over Europe, that all these traffic management plans, for example, towards 2015, are evaluated taking into account local measures, but then they are not combined with concentration changes which are caused by European or regional policy. And so we really believe that by taking into account both, as well as reductions due to European and regional policy, in combination with local air quality management plans, gives you the best estimate for true concentrations in the future. Okay, maybe I take a last question because it's almost 4 o'clock Central European time. So maybe last question is, how long lasts the simulation in the web-based tool? For example, one with detail and Antwerp study. I think typical model simulations last for a couple of hours. Let's say typically something between 8 and, let's say, 6 and 10 hours. Depending on the complexity of the grid, the complexity of the region of interest, this can be a bit longer. In the current setup for the region in Flanders, we've made a decision to limit the number of receptor points that can be used in one simulation. So from that perspective, or in that way, we limit the simulation time just by the number of receptor points that can be selected by the IVM traffic user. But this is a configuration issue. So if there is enough computer power available, this is something that can be discussed during the configuration phase. But typically it takes a couple of hours up to, let's say, 1 or 1.5 days for a very complex domain that are typical simulation times. So I think we come to the end of the webinar. I would like to thank everybody for attending the seminar. I hope it was useful for you. Yeah, if you have more questions, yeah, I'm very happy to answer those, and you always can send me an email on steinjansen@vito.be. All the questions that were submitted during the seminar will be collected, and we will provide you some feedback within the coming days. So that's promised from our side. So thank you also for submitting questions, and we will come back to you about these. Thank you very much, and see you around.